Welcome, everybody. Thank you for joining this talk today. I want to inform you about the news on what we've been working on and what we released on the Embedded Academy. And we'll have a little recap and then go also into the e-learnings and have a sneak peek in the new learning units which we have released, and I will also inform you about what we are working on and what to expect within the next weeks. So thank you for joining. Now we see the webpage of the Embedded Academy, which you certainly know. On the first page, we have some direct links, for example, to the news, which we'll have a look at. These are the new courses. This is like the full portfolio, free glossary, list of abbreviations. Also, we are providing individual e-learnings, and we have embedded and charging trainings, both in English and German, and some are online and others are at our location in Regensburg, but it's also possible to have in-house trainings where the trainers are coming to your place. So this is like the general web page with further education consulting, and here you see the numbers are growing. We've been releasing quite a lot recently. So first of all, we'll have a look at the news page. I will scroll down now completely. For the ones who had a look previously, we cleaned up the news because like what happened in 2022 is not that relevant anymore, or it's part of a learning portfolio and it's there and it's available. And with the news, we want to inform you what's all the new content coming up. Yeah? We started this year with information security as a new course, giving you an insight into information security with data privacy and data security and IT security. Then we continued with a new course on introduction to serial bus systems. This is important for more or less every bus system you're using. And as it's like the general understanding, this is providing the foundation to understand serial bus systems and to have an easier way reading the manuals for these 50 plus types of different serial bus systems which exist out there. Then glossary units, they are free of charge, so you can find them. We saw this on the starting page, and we added quite a lot of new glossary units this year. So this is like clock signal, access code, and then the courses we started, we are not waiting to have like the full course ready, but we are publishing the course and e-learnings as they are getting ready, because even if you don't have a full course in the beginning, the e-learnings inside are beneficial nevertheless. And as you have access to everything, this should be something you have available as soon as possible. And this means that we are often doing an update later, or not an update, it's like adding new e-learning to the course until the course is finished. And so in March, we finished the course on information security, had some further glossary units on bitrate, baud rate, substitution, permutation, XOR, which you need for serial bus systems as well as for encryption. Then the next release on serial bus systems, another glossary unit, another glossary unit, and there's more. And this was the last of the serial bus systems. So we completed, no, I think there's one more. So then we have more glossary units. And then end of May, we did our first live event on what's new in the Embedded Academy. And we are going to do this on a regular basis now. So this was done in end of May. In June, we had quite a lot of holidays. So there was a gap in releases. But since beginning of July, we released something every week. Yeah, every week there's something new. Beginning of July, we added to Automotive Spice the process training product release. On Automotive Spice overall, we have 5 courses and 5 courses containing several e-learnings for the different processes, as Automotive Spice has like 30 plus processes. And this was a new one on product release. Then we started a completely new course on power electronics fundamentals with the first e-learning components of power electronics, and another new course, battery and battery systems, with the first course battery and the second one battery system. For power electronics, we continue to release then half-bridge. And then we started yet another course on cyclic redundancy check. And this was in end of or middle of August, where we had our last presentation on what is new. And then we are starting with the things which we did since the last event. I would like to have a short look at the YouTube channel. So on YouTube, you find these events we do, like Embedded Academy, What's New. So this was the one in May. This was the one we did in August. The intention is to do this every other month. So it would have been May, July, and September. But in July, it was also vacation time. So we postponed until mid-end of August. So now it's a very short time in between presentations. There was a lot last time I presented, and there will be a little less this time and will be shorter. And the next will be most likely in November or maybe beginning of December, where we will again show and introduce what's new. So this is the event today. This before we had in German, now it's English. So we'll have a look back at the news page. The power electronics fundamentals, giving an introduction into power electronics, is now finished. This was the last e-learning, the 4th of them, thermal design and assembly. We'll have a look into this. For cyclic redundancy check, CRC, the first e-learning was the concepts, and then there are e-learnings really giving concrete examples showing how certain checksums are calculated. And for this, we are depicting like typical ones, which are often used in praxis, and at the same time can be displayed very well as e-learning, because if they get too long, it will be difficult. So CRC 8 is really used very often. It's one e-learning. Then we have the second one, CRC 16. So you see sometimes there's a little bit a gap in between to get finished. This course is completely still in German. We are currently working on translating it into English. The first part, the CRC introduction, will be released next week. And we have planned to release all of the CRC e-learnings also in English until end of October. Similar is for measurement technology using strain gauges. There we have continued generating content. We are continuing working on this, and this also is done first in German and will be provided then in English. But we also released some of the content in English, which is now available in English. So it's going in parallel. We just do German first, and with a time delay of 1 to 2 months, you will have it also in English. And the last 4 years, we generated a lot of new content, meaning that sometimes you also need to rework. You get customer feedbacks, you review, we get questions, and then we rework the didactics or integrate new content. And this is what we started here with electrified powertrain. We did an update lesson for power electronics in the part basics of power electronics. So this is happening too. So we are generating new content, but we're also improving and updating of what we released so far. So this is the news for now. Like I said, we've been releasing something new every week since beginning of July, and we hope to maintain this at least until Christmas, and of course to continue like this next year with having something new for especially the people who signed in for the full year subscription, that they get something new on a regular basis, and to motivate them to continue learning and growing their know-how. Okay, then just a short overview on the e-learning portfolio, what I mentioned before. So now with all these new courses, we have lots of automotive stuff in the beginning, but it's the fact that we put it alphabetically. So automotive is the first in the alphabet. It doesn't mean that it's only automotive. It's a lot more other content, but it starts with the letter A. So it's automotive bus systems, automotive cybersecurity. And as I said, for automotive SPICE, we have 5 courses. So we split it up into 5 courses because the target audience is not always the same, and because we're trying to have the course length, like the ideal course length is, I would say, around 2 hours. And we're targeting to get there more and more. Like, for example, these supporting processes is an ideal time. We have AUTOSAR. And then we can have a look at these new courses, which is now in the growing portfolio. It's battery and battery system fundamentals, all the e-mobility stuff we had before, control of electrical machines, e-mobility, electrical machines and electrified powertrain, and electronics and electrical fundamentals. As you saw, we did an update here. For information security, it's further below. But we started these kind of topics also before with cryptography, which is a very extensive course and is more or less explaining all encryption methods which are currently in use. Embedded software basics, EV charging, we also have since a longer time. And what's quite new here is information security. It's completely new. Introduction to serial bus system is new. Here we are working on and adding content. You see here it's just 35 minutes, but the German course already has 60 minutes of content, and we are continue working on this. NVH we have since a longer time, and operating system, real-time operating system. New is the course on power electronic fundamentals, and vector control we have also since a longer time. And also new is cyclic redundancy check. And as I said, it's available in German right now for first English e-learning, and the course will be available next week. And we hope that we will publish everything within October, so that you have a full course also available in English by the end of October. So this was a look of our overall portfolio. If you want to have like only a certain topic, then you can press a button here. For example, everything which is relevant for control engineering, we have control of electrical machines and vector control. Everything which is relevant for IT security, we have automotive cybersecurity, cryptography, information security. So then you don't have all the topics, you can choose your field. Okay, so now have a look. Now we should have a look at the content. I'll start with measurement technology using strain gauges. It's a little further away from embedded topics, but it has many, many aspects in common, like the electronics, the filters, like the control technology know-how, and so on. So it's really fitting also to the rest of the field. In English, as I said, it's just for introduction, motivation, and properties, which you can see here. And in German, there is more. Yeah. So we can have like a short look at the first introduction here, and then also have to look into the German part, even though from a language point of view, it's not understandable, but I can switch off the explanation, the German explanation, and can fill in English myself.
In this C-learning, we are dealing with electrical strain gauges. In general, there are also other kinds of strain gauges. Click on the 5 thought bubbles to find out what they are. Capacitive strain gauges.
So this is like a general introduction. And then we can have a look at the properties.
Now let's look at some properties of strain gauges. Strain gauges are printed using the photochemical process. The grid is usually made of karma or constantan, while the carrier film is made of polyamide, polyurethane or phenolic resin. The strain gauges usually allow a strain of 3%. Since they are designed to measure strain in only one direction, the transverse sensitivity should be as low as possible. In most cases it is less than 1 per miller. Depending on the application, the strain gauges have an active grid length of 0.6 millimeters to 15 centimeters. The longer ones are used, for example, when measurements are to be made over a larger uneven area. Due to the photochemical process, the resistance can be adjusted very precisely, mostly 120 ohms are chosen. But there are also variants with 350, 700 and 1000 ohms. Materials tend to expand when exposed to heat. The amount of expansion is described by an expansion coefficient. For example, mild steel has a material expansion coefficient of 11 millionths per Kelvin. The ppm stands for parts per million. This means that at an increase in temperature of 1 Kelvin, mild steel expands by 11 micrometers per meter. But the user is only interested in a strain that is caused by a load. He does not want to see pure thermal expansion. Therefore, the conductor material should compensate for the imposed strain. The required term is composed of the impeded thermal expansion of the conductor material and its specific electrical resistance. Producers develop strain gauges that are temperature compensated for a specific material by specifically selecting the conductor materials. However, a detailed explanation would go beyond the scope at this point. If you want to carry out a measurement on mild steel, you should choose a strain gauge that is temperature compensated for mild steel.
So this is like the properties, the explanation. This is the basic course where you get the explanation on strain gauges themselves. And then the next course, which we just published in German, it's on understanding now I'm just lacking the word for, I have to look it up. For the strain or the elongation and of the material. And this means that we explain the physical properties in this training. And this is, even though it's in German, I would like to have a look because we will publish in English soon. So this is like the German course, and here you see that that has the introduction and also the physical basics, which will come in English soon.
Grundsätzlich ist Dehnung eine Anwendung.
So I will switch off the explanation in German. First part is explaining what is the strain. So you have like a cylinder which looks like this, and if you if it gets longer, then of course the thickness is also reduced, and the other way around. So you see a picture on what this means. Then in the next one you get the variables explained, which of course from a picture point of view it's the same in English as in German. And what I would like to have as a picture is the strain and tension, to say, okay, I have tension, and what does it mean for strain? And there is the standard picture which is explaining this, and you have a linear area, and in this linear area we are working with strain gauges, and you have an area where you have a material is changing, and if the strain is getting too big, this means that it cannot get back into the old form. And this is explained here in stepwise, so you can switch from one to the next, and you get an explanation. For example, for here the Hooke's law, or how you call it, explaining that you have strain and tension have a linear connection, and then you have an explanation from the next area where the point, I would say it's the point of no return, because there the material will change forever and you're not getting back to the original. And here, when it even can break, so the material is gone forever. And these parts will be released by my colleagues. Maybe you already have a feeling that it's not my main area of expertise, will be published soon, but there are some people who studied physics who are working on this, and I'm more in the electrical field. So next topic I would like to have a look at is the power electronics fundamentals. Power electronics fundamentals deals with electronics which is needed to switch power, meaning that you have higher voltages and higher currents than usually in electronics. And we, in the last event, we already presented basics of power electronics, the components of power electronics, the half bridge with an example for controlling an AC motor. And what's new is thermal design and assembly. And this is really important for power electronics. Like I said, the current and the voltage is higher, far higher than in normal electronics. This means that you have a lot higher energy within the electronics, and you always have losses. And these energy losses within your electronics have to be handled somehow. And for this reason, thermal design is important. And this is the fourth e-learning in this introductory course, which the introductory course is giving you all the aspects you need to consider and a general understanding of power electronics. For this, I would like to have first the explained.
We begin this chapter with a focus on thermal load.
I would like to have explained the thermal resistance so that you have a general understanding there, and then we get into the thermal design.
An important concept in this context is thermal resistance. Thermal resistance is the property of a particular component. It measures the temperature difference when a unit of heat energy flows through it in unit time. Hence, it basically defines how an object of material resists a heat flow. It is notated by our index TH and given in kelvins per watt. We want to look at two examples which nicely illustrate the concept of thermal resistance. First, we look at the thermal resistance of a pot. We want to get the water within the pot boiling when we switch on the stove. Hence, the thermal resistance of this pot needs to be as low as possible to boil the water as fast as possible. We use the same effect in a different direction with the insulation of a building. Depending on the insulation material, the thermal resistance should be as high as possible, such that the heat will stay inside the building and not go outside. These two examples highlight the fact that the RTH value is a property of the component or material itself, as both of them resist the heat flow differently. We can now make statements on the design criteria. Looking again at the diagram, we can conclude that one design criterion for power electronics is based on the heating of the components. Namely, we have to consider the self-heating of the component and the losses due to the heating of the cooling medium.
The diagram was explained before. So you have thermal cycles, and you have like the general curve, which is the temperature curve. So this is the heating and this is the temperature curve, and you have a maximum temperature which you should not reach for the junction temperature.
Means for the first formula, we take into account the cooling temperature and the power loss is multiplied by the thermal resistance. This value, which is a change in temperature, needs to be smaller than the allowed maximum temperature of the components. The second design criterion is the load by thermal cycles. This needs to be lower than the cycle lifetime. Hence, the second formula corresponds to the influence of the temperature on the life cycle of the power module.
Okay, these are the design criteria that with the cooling you get there and you don't reach the maximum temperature. And then I would like to have a short look at like the one example on water cooling, so that you have an understanding how the explanation is done.
In comparison, we have a look at a power module that is water cooled. At the bottom, we see the water cooler and its housing. In a water-cooled system, we have a direct connection of the water to the cooling circuit and a better possibility to bring the heat into the cooling medium. This also results in a better thermal resistance value.
Okay, now this course is finished on power electronics fundamentals, so we provide everything, the full course by now. Yeah, so this was the last bit of information which was still missing. And now I will go to the cyclic redundancy check, even though it's currently only available in German. So cyclic redundancy check, we start with a definition, and then we continue with CRC 8 and CRC 16 examples. Here in this picture, you see, we start with
Die
functioning.
CRT-Checksumme ist eine kurze.
And I will also switch out the German explanation. So for CRC, you have on the one hand the data, and then you have a CRC checksum. The CRC is taking the data and generating, depending on algorithm and a polynomial, the value. Yeah. The polynomial is important to understand for the next step. So you have a sender and a receiver of information, and this can be seen also if you are within an electronic control unit. So then it's like the sender was the calculation which is saved, and the receiver is the one who is calculating again. But normally you are using this for communication via serial bus systems, and you have a generator polynomial, which more or less is the key which is used, and for the polynomial, the rule is that you have for the calculation, the grade is calculated like the polynomial minus 1 bit. So if you have 4 bits as generator polynomial, you get the grade 3 for the polynomial. I would say that we are going into the examples to have a look how this is used. Yeah. Here is an example for CRC 8. And then here we have, for example, the generator polynomial grade 8. And this means it has 9 bits. We have the message, which is the input. And then we take the generator polynomial and we do an XOR every time. XOR means that if it's equal, like 1 and 1 is getting 0, and 1 and 0 is getting 1. So we're calculating this and in a continued way. Yeah, more or less, I would leave it there. You see that the polynomial is there, the calculation is explained, and we have it, the CRC for the sender, for the one who is receiving it, like taking the CRC and do something with this CRC, and then we have an explanation how to find out if a message was correct or not correct. And this is explained for the CRC8, and it's also explained in the same structure for CRC16 to get an understanding on how it's working. Yeah, so I don't want to do a training now out of this showing what's new, but this is what we've been working on and what we're going to release until the end of October. We will continue working on these several paths, yeah. And I would be also happy to get feedback on what additional topics you would like us to implement so that we are going in the right direction in our offer for you. Do we have any questions concerning presentation, content, roadmap, whatever? So if there are no questions, I would like to thank you for your time and joining in today. As I said, this was only 5 weeks of e-learning content. When we do the next event by the end of November, there will be certainly more news to provide. And I would also recommend to have a look on YouTube on what we presented, especially the last time by the end of August, because there was lots of news and lots of interesting insight into especially battery systems, serial bus systems, and power electronics. Thank you for joining, and I hope you have time again to come back in November. Thank you. Bye-bye.